Hello friends, welcome back. In this tutorial we will learn methods of evaluating algebraic limits at infinity. First of all, we need to remember some points. First is limit x tends to infinity 1 upon x is equal to 0, and limit x tends to infinity 1 upon x square is also equals to 0, and limit x tends to infinity c upon x raised to power n is also equals to 0, where n is greater than 0. Second is limit x tends to minus infinity 1 upon x is equal to 0, and limit x tends to minus infinity 1 upon x square is also equals to 0. And limit x tends to minus infinity c upon x raised to power n is also equals to 0. Now these points will be very helpful for us to solve the problems. Now let us solve the first problem. Suppose we have to evaluate limit x tends to infinity ax square plus bx plus c upon dx square plus ex plus f. So in these types of questions, what we need to do, how we will solve this? In this question, what we will do, we will divide numerator and denominator both by x square. So these types of questions will be solved like this. So we will divide both numerator and denominator by x square. So we will get limit x tends to infinity a plus b upon x plus c upon x square d plus e upon x plus f upon x square. So as I have told you already that limit x tends to infinity 1 upon x and 1 upon x square, they both are equal to 0. So this term, this term, this term and this term, they will be equal to 0. So what we will get? We will get a upon d. So this is the answer. Now let us solve some similar questions. Question. Now we have to evaluate limit x tends to infinity 5x minus 6 upon root 4x square plus 9. So in this case, what we will do, we will divide both numerator and denominator by x. So we will get limit x tends to infinity 5 minus 6 by x root 4 plus 9 upon x square. So it will be equal to 5 upon root 4, right? Now let us solve another question. Limit x tends to infinity root x plus c minus root x. we have to evaluate this. So in this case, what we will do, we will multiply numerator and denominator both by the conjugate of this expression. So we will get limit x tends to infinity root x plus c plus minus root x into root x plus c plus root x and divided by root x plus c plus root x. So it will be equal to limit x tends to infinity root x into, now see, a minus b into a plus b, it is equal to a square minus b square. So it will be equal to x plus c minus x upon root x plus c plus root x, and it is equal to limit x tends to infinity c root x upon root x plus c plus root x. Now we will divide both numerator and denominator by root x. So we will get limit x tends to infinity c upon root 1 plus c by x plus root 1, right? So it will be equal to c upon root 1 plus root 1, it will be equal to c upon 2. Now let us solve some more questions which are similar to this question, in which we have to multiply both numerator and denominator by the conjugate of the expression. So let us solve another similar question. Now we have to evaluate limit x tends to infinity root x square plus x plus 1 minus root x square plus 1, right? It will be equal to limit x tends to infinity root x square plus x plus 1 minus root x square plus 1 into root x square plus x plus 1 plus root x square plus 1 upon root x square plus x plus 1 plus root x square plus 1. So in this type of questions, what we have done, we have multiplied both numerator and denominator by the conjugate of the expression. So it will be equal to limit x tends to infinity. Now see here, a minus b into a plus b is what? A square minus b square. So it will be equal to x square plus x plus 1 minus x square plus 1 divided by okay, so it is equal to this expression, limit x tends to infinity. In numerator we have only x and denominator will remain same. Now what we will do, we will divide both numerator and denominator by x. So we will get limit x tends to infinity 1 upon root 1 plus 1 upon x plus 1 upon x square plus root 1 plus 1 upon x square. So it will be equal to 1 upon root 1 plus root 1. So it is equal to 1 upon root 2. Right? Now let us solve one more question. This question is little bit confusing. It seems confusing, but it is very simple. See, we have to evaluate limit n tends to infinity n factorial upon n minus 1 factorial minus n factorial. So in this case, what we will do, we will divide both numerator and denominator by n factorial. So we will have limit n tends to infinity 1 upon n minus 1 factorial upon n factorial minus n factorial upon n factorial. So it is equal to limit n tends to infinity 1 upon n minus 1 minus 1, and it will be equal to limit n tends to infinity 1 upon n, and it should be equal to 0. So this question seemed a little bit confusing, but it was very simple. Now let us solve one more question. This is the last question of this video. Limit x tends to infinity x plus 1 raised to power 100 plus x plus 2 raised to power 100 plus so on x plus 100 raised to power 100 upon x raised to power 10 plus 10 raised to power 10. Sorry, this question is little bit wrong. It is in denominator it is x raised to power 100 plus 10 raised to power 100. Okay, it was a mistake. Now I have rectified it. Now let us solve this. So in this case, what we will do, we will divide both numerator and denominator by x raised to power 100. Right? So it will be equal to limit x tends to infinity 1 plus 1 upon x raised to power 100 1 plus 2 upon x raised to power 100 plus so on 1 plus 100 raised to power x upon 100 upon the denominator. Also we have to divide the denominator by x raised to power 100. So we will get 1 plus 10 by x raised to power 100. So it will be equal to, we know that when limit x tends to infinity 1 upon x will be equal to 0. So these terms 1 upon x, 2 by x, 100 by x and this 10 by x, they will become 0. So we will have 1 plus 1 plus 1 so on up to 100 times upon 1, and it will be equal to 100. So here we have solved some questions in which we have discussed the methods of finding the limits at infinity.